Hello everybody, this is Mr. Pils, and I wanted to go through the SEPUP Seasons Simulation Lab, which is in day 4 of our installation unit. So in order to follow along with me, you can open up the SEPUP Season Simulation Lab along with the directions provided by the DOE, and I'm going to be using the Google Sheet version of this student data sheet just because rather than work with this Google Doc with a data table, I'd rather work with a Google Sheet with my data table. That way, now this is fake data, but just to kind of show you why we're working with this. Since we're in the virtual realm, we want to let the computers do some of the work. So we can actually take any data chart that we have here and we can turn it into a line graph. Now, the purpose of having a line graph is going to make it way easier to see trends and relationships and see how one variable is going to affect another variable, rather than looking through just numbers on a data table. It should be easier to see once we turn that data into a visual element, a line graph in particular. So I'll be deleting this tab with my example here, but just for you to navigate on the bottom, if you click this little table of contents, it should bring you to any of the tables that we're using, and you can also use these arrows on the bottom to navigate as well. I'm going to start with table 1A in just a second. First, I'm going to go to the directions. So if you haven't read the introduction and the directions to this lab, I would pause the video for a quick moment and take a minute to read it, so that way you can kind of gain some context and some understanding as to why we're doing this lab, along with the rest of the work that you've been doing this lesson. It goes through the settings and the data outputs, just like I'll be doing in just a moment. And let's take a look at the introduction right here. So we're going to be exploring 4 cities on the map: Anchorage, Alaska; Chicago, Illinois; Quito, Alaska; and Melbourne, Australia. Please describe each location's latitude and if it is north or south of the equator, or if it's in the northern or southern hemisphere. So, sorry about that notification there. Here's our introduction. We see our cities and their latitudes, along with a couple other important lines of latitude. So we have the equator, which is 0 degrees latitude. Any city north of the equator is going to be in the northern hemisphere, and any city south of the equator is going to be in the southern hemisphere. If you highlight the city, it'll highlight the latitude, the line of latitude that the city lies on. So Chicago, Illinois, that's 42 degrees north latitude. Here in New York, we're almost 41 degrees north latitude, so they're going to have very similar daylight hours and changes to what we have here in New York, and it may or may not be different as we change our latitude. So here's Anchorage, Alaska, very far northeast Quito, Ecuador. Ecuador is actually intersected by the equator. It's how the country got its name. And then we have Melbourne, Australia, which is down in the southern hemisphere. We also have the Tropic of Cancer and the Tropic of Capricorn, which are both 23.5 degrees latitude. The Tropic of Cancer is north of the equator. The Tropic of Capricorn is south of the equator. And as we kind of look at the relationship between lines of latitude and the Earth's revolution, we'll see why these lines are important on very specific dates of the year too. So let's start getting into this lab. We're going to make sure that the lab is set so that the Earth is tilted at 23.5 degrees to start. If you wanted to show the tropics, you could, but I'm going to have it selected off right now. And I'm going to be paying attention to the first city in our data table, which is actually going to be Melbourne, Australia. I'm going to make my window a little bit smaller so I can look at both of these things at the same time. And table 1A here is asking for the daylight hours. You're going to put it in exactly how it says it here in the SEPUP Sim Lab. So for Melbourne, Australia in January, I have 14 hours and 29 minutes of daylight. I'm going to go to the next month. February, I have 13 hours and 30 minutes of daylight. Now, if you wanted to do all of your cities at once, if you'd rather do that, you can. I'm just going to show you with Melbourne, Australia, so I'm just going to continue entering this data here. April 1108. Maybe I'll speed up the video so you don't have to watch me put in each one of these things. Okay, After you do Melbourne, then you're going to go on to the next city. You'll do Anchorage, and you'll do that same process again for the Earth tilted at 23.5 degrees. Now, once you're finished with your entire data table, you're going to select all of the cells here in the sheet. You're going to highlight everything. And right now I don't have my data in, so I wouldn't have a good data table. It wouldn't show up correctly. So I'm going to just model with just the data that I input. So I'm going to click Insert on top. I'm going to go down to where it says Chart, even though we know that they're graphs in science class. Open that up. And it should give you a line graph. Now, if it doesn't give you a line graph, just make sure that you select this very first one that says line chart. And this is just giving me Melbourne right now. If I had another city's data in, this is the same data, so it would be the same line. But it would give me pretty good looking line graph like we saw before. There's one line on top of the other, so it's not differentiating these two, but when you have different data in, it's going to show you the differences, just like this first one over here. So input all of your data, then make your sheet for the average daylight hours. Then you'll do the same thing for the temperature. So just like I showed you, the next thing we're going to do is we're going to add the temperature, and make sure that when you're inputting your temperature data that you're inputting it in degrees Celsius. Also make sure that you're putting the negative values in if there is a negative value that's being shown. So in January, Melbourne, Australia would be 19 degrees Celsius, and I would just put it in like that. After you have all of your data tables shown, it might be helpful for you to just copy and paste all of them onto one table, so that way you can kind of look at these trends as you're answering the analysis questions that are also accompanying this lab. Now you don't have to do any of these graphs because we did that in Sheets. Hopefully it should save you some time. And then you're going to use the visual elements, the data, to notice any similarities and differences that you see in your data. So again, a data table is hard to notice trends and relationships and patterns, but using those line graphs should make it a little bit easier. And when you're using data to describe changes, you want to use the word increases, decreases, and stays the same. So for this one, when you say what similarities and differences did you notice between the average day length and the average temperature, try to consider this. As the average daylight length increases, what happens to the average temperature for that location? Or vice versa. If the average day length is decreasing, what is happening to the average temperature data? That's one way that you can describe a relationship in science. So numbers 1, 2, 3, and 4 are pretty much all based on your data. Number 5, it's going to ask you to kind of hypothesize what's going on. So there is a correlation between daylight length and temperature. It's asking you to explain a possible cause for correlation, and we're going to be looking at this as the unit goes on throughout the week and throughout the month. I also want to just discuss number 8 because we have a picture. I always love questions with a picture. So here the picture is showing us the positioning of the sun at sunset in relationship to this like city backdrop that we have. It's beautiful. I wish that I lived in a house that had a view like that. And the question is asking, where do you think the sun would set in this location in the winter? And we're talking about our winter, which is like December, January. Would it be to the left or to the right of the photograph, and why? So based on the dates that we see there and the position, would the December sunset be to the left of the picture or to be to the right of the picture? One other thing that we didn't talk about right here is question 8. So it says many people incorrectly believe that the weather is hotter in the summer because the Earth is closer to the sun, and then it would be cooler in the winter because it's further from the sun. And your data should show something a little bit different than that. And again, we have the distance from the sun down here, and we have a spot for you to input that data right here in 1B, where it's asking for which hemisphere is pointed towards the sun and the distance of the Earth from the sun. So it says use 2 pieces of data or evidence in your lab to explain why the data in the collected from the lab tells us about the seasons. So when answering this question, you're going to take evidence from this lab to So in order to answer that question, you're going to look at your data about the Earth's distance from the sun throughout the year, and you're going to explain why that's a misconception and use the data that you have as evidence. You say, like, no, it's not true because look at the Earth's distance from the sun in this month, as opposed to look at the Earth's distance from this month, look at the temperature of the Earth in this month. That's how you're going to use evidence and data in your answer. I hope this was helpful. Have a nice day. I'll see you guys next time.